Stupid candy.
So the same idea yesterday of like you multiply to every single term. You're going to do the same rule. Now you're going to divide to every single term. When you want to divide, they'll actually use a division symbol. So multiplication, there's no symbol. Division, they have to write it. It would look something like this. So what this means is you want to do the entire polynomial divided by 6x. That's what that means. And we distribute it, but we distribute it with division. So it would look like this. I'm going to circle this 6x, and I'm going to distribute to every single term. That means I'm going to divide every single term by 6x. They've also shown that two different ways. So the first way, that's just showing you the polynomial divided by 6x. You could also write that as a fraction. So one really big fraction. This means the exact same thing. Okay, they've said that entire polynomial divided by 6x means the same thing as what I just did in the brackets before. And again, you can break up that 6x to go to every single term. And you could actually write these all as individual fractions, which looks like this. And then it shows, okay, what I'm doing is I'm taking every term and I'm dividing it by 6x. Every term divided by 6x. Every term divided by 6x.
Make this look so easy that as soon as we get to like the next question,
it's not bad. So I kind of like, I'll try to pair it up here so you can kind of see. Like that one's there. This one's here. And this one's here. You'll notice that if there's a subtraction, like this is a subtract 24x, they put the subtraction in between the fractions. You could also put like plus and then put a negative on the 24. I don't know, I wouldn't really do that. We rather just put the negative in front. It's easier. Awesome. Dividing these things. Now look at the last one on the right, where each one's an individual fraction. Yeah. Yeah, if you wanted. Yeah. If you want to think about what all the numbers would be and stuff, and then put the symbols in between. Yeah, that's fine. So if I look at that one on the right, the one with the 3 individual fractions, if I focus just on fraction, 18x cubed divided by 6x. The way that we do that is the same with multiplication. You do numbers with numbers and letters with letters. So 18 divided by 6, if you tried that, it was 6, 12, 18, it's 3. Remember, dividing, if you're trying to do it in your head, is you're breaking something into groups. So if you skip count by the bottom number, skip count by 6s, you'll figure out what it would be. The letters, so x to the power of 3 divided by x, that might be a little different for us. So when we multiplied, what did we do to the exponents? We added them. When you divide, you subtract. Yeah. So in this case, this would be x to the power of 3, and there's an invisible 1 at the bottom. So it'd be 3 minus 1, which is 2. X to the power of 2. You subtract exponents when you're dividing. Then I'm going to have a plus sign. Then I'm going to do the middle fraction. Again, numbers with numbers and letters with letters. 12 divided by 6 is 2. X squared divided by x to the power of 1 would become x to the power of 1, because 2 minus 1 is 1. Then I have a minus sign. And then I have 24x divided by 6x. 24 divided by 6 is 4. X divided by x. So you had x to the power of 1 divided by x to the power of 1. 1 minus 1 is 0. That means you have x to the power of 0, which we don't write. You just don't write x's anymore. A term that you might have heard math teachers use is they would say they cancel each other out. It's not like a proper way to say that. You'll even see me say that from time to time just because it's an easy way to discuss it. But they're not canceling each other out. What's happening is you're going exponent minus exponent, 1 minus 1 is x to the power of 0, which means there's no x's, so I don't write any x's. That's the mathematical thing that's happening. Awesome. This answer, 3x squared plus 2x minus 4. Yeah. It's not that bad, right? So if we look at the next one, we have this big polynomial divided by 3a. So what I do is I distribute this 3a to these three terms. And when I do that, I'm dividing them so that this question becomes 12a to the power of 5 divided by 3a. The minus sign is there. Now doing 15a squared divided by 3a. Plus, I'm doing 6a divided by 3a. And again, you then just do each term individually, just like multiplication, right? We distributed multiplication, and then we calculated. So if you look at the first fraction, we have the red fraction. We have 12 divided by 3. 12 divided by 3 is 4, right? 3, 6, 9, 12. A to the power of 5 divided by a to the power of 1 becomes a to the power of 4. We subtract exponents. The middle, the blue one, numbers with numbers. 15 divided by 3 is 5. A squared divided by a is a to the power of 1. And we don't write a to the power of 1. We just put a. We assume that the exponent is 1 if we don't put anything. The last one is now a plus symbol. 6 divided by 3 is 2. A divided by a cancels out, or 1 minus 1 is 0. A to the power is 0, we don't write.
Yeah. Why were you laughing?
Because Joey was answering the question as I was reading it. He was saying what I was saying. He's just a step ahead of me. Awesome. Not bad, right? Same idea. It's just distribution. You look at this one, it's more complex because there's more letters, but it's the same process. Right? Like all they can do is make the question bigger. They really don't make it harder. There's just more steps. So when you see a massive question, try your best to not let it overwhelm you and just go through the process because it's the same process every time. Right? I have a big polynomial here. Like this is a very polynomial. And then I'm dividing by another polynomial. The way we handle that is we just distribute it. So the way I look at this, I need to divide this to x squared y, divide this to x squared y squared, divide this to x cubed y, divide this all the way out here to x to the 6 y squared. Yeah, Joe.
Would we not do the y in the second one?
Which, like this one? Second one? So this would be, when you go to do it, yeah, the y's are just now not there. So again, I write these as individual fractions first, just so I can kind of see what's going on. So the first term was x 6 y squared, and I'm now dividing it by x squared y. That's the first term. Then I have a minus. Now I have my blue distribution. So I have x cubed y divided by x squared y. Then I have my third term, which is my green. I have x squared y cubed divided by x squared y. Subtract the fourth term. Fourth term is my red arrow. It's x squared y divided by x squared y. And I do each fraction individually. When I look at the purple fraction, numbers go with numbers, letters go with letters. There are no numbers, meaning there's no coefficients, right? There's no number in front of the letters. So I move on to letters go with letters. Letters can only divide by the same letter. Okay, so x to the 6 can only divide by the x squared. Just the x's go together. I have 6, I have 2, so 6 minus 2 would give me x to the power of 4. And then the y would go together. So I have y squared divided by y to the 1. 2 minus 1 is 1. That first comes y to the power 4, y to the power 1. X to the power 4, y to the power 1. I think I said y both times. Then it's a subtraction symbol. And move on to the blue term. X's with x's, y's with y's. X cubed divided by x squared becomes x to the power of 1. Y to the 1 divided by y to the 1 would become y to the 0. We don't write y to the zeros. That means there are none there. So we just don't have a y anymore in that blue term. It's gone. Plus the green term. X's with x's, y's with y's. X squared divided by x squared, 2 minus 2 is 0. We don't write x to the power of 0, so the x's are gone. Y to the 3 divided by y to the 1 would become y to the 2. Subtract. Now, this is the trickiest one. Okay, so this one gets a lot of people. So x squared divided by x squared would become x to the 0. Agreed? Awesome. Y divided by y would become y to the 0. So we won't write x or y. So they're both gone. And what people do is they say they cancel them out and then they don't write any there. But you do need to have something there to represent what happened. The way I'm going to show you why what happens is an old division rule you learned in like grade 4. I'm pretty sure you learned at grade 4. And what you learned a long, long time ago was if you had a 2 divided by 2, it equaled 1. If you had 5 divided by 5, it equaled 1. Right? And the rule that you learned in grade 4 was if you have something you divide it by itself, it equals 1. So you got really clever in grade 4, and you probably went home and you're probably like, hey, if I had 1 million divided by 1 million, you know what the answer is. And you feel so smart because you're in grade 4. Right? 1 million divided by 1 million is because 0. And you get it wrong. Anything divided by itself is 1. That rule still applies with letters. So if you look at the red term, this is something divided by itself. So something divided by itself should always equal 1. So we actually put a 1 there. Yeah, Joe. Yeah. So if it's the identical term, we use this old rule of like any divided by itself is 1, and we apply it. It's funny because that is such a simple rule. Like literally learned it way back in grade 4, but then we forget it when it comes to letters all of a sudden. Right? We forget in grade 9, we forget in grade 10, we forget in grade 11, we forget in grade 12. Right? Like the skills you're learning right now we just apply them in grade 10, 11, 12. That's all that happens. So you use these skills the rest of the way. And people forget basic ones like that. Okay? So anything divided by itself is 1. Yeah.
How come the second term, there was a y divided by y and we just can't do it?
Oh, okay. So, gentlemen, Harper asked a good question. If you look at the blue term, the x cubed times y divided by x squared y, this one right here. She's saying, why don't we write anything for y divided by y? Okay, when I did my x's, x cubed x squared, that equals x, that makes sense. Y divided by y is something divided by itself, which equals 1. So this technically is x times 1. But we don't write times 1 because anything times 1 is itself. So that's why we don't write anything there. But there is an invisible like times 1 there. Yeah. We just don't write it. It actually like kind of explains a rule that you learn next year. The rule that you learn next year is that anything to the power of 0, so y to the power of 0 equals 1. Because you had something divided by itself to get something to the power of 0, which equaled 1. So if you understand what I'm talking about, then you're just going to have a little bit of a leg up next year. When you see the y to the power of 0s, you're going to be like, oh, that's just 1. Because it meant y divided by y, which is itself divided by itself, which is 1. Yeah. Next little bit here. Now we got letters and numbers. So we're going to distribute this all the way across. So we're going to become, we'll do the first one in blue, 20a to the 5b squared divided by negative 4ab squared. Then we have a subtraction. Distributed to the second one. We have 4a cubed b cubed divided by negative 4ab squared. Then we have a plus. We're going to distribute it to the middle. We now have 12a squared b to the 4 divided by negative 4ab squared. And some interesting things happen with this one. Some things that we haven't seen before. So I'm going to let you write this down. Then we're going to go through each term so you can see what happens. Yeah, Joe.
For the minus sign carry over for offer.
And that's what makes this an interesting question. Because that negative sign on the bottom, we have to deal with that somehow. We're not allowed to leave negatives on the bottom. We have to do something with them, so it does change things. So if you've got that written down, we're going to go through it now. What I was just talking with Joey about is that the negative in the denominator, so the negative on the bottom, is going to have an effect on our question that we haven't seen before. So if you look at the blue term, numbers with numbers. So I have 20 divided by negative 4. A positive divided by a negative is always going to be a negative. So I know that my answer has to be negative. And then I do 20 divided by 4, which is 5. So I use my knowledge of like positive divided by negative, and then I just focus on the numbers. I then have a to the 5 divided by a to the 1, which is a to the 4. I have b squared divided by b squared, which is b to the 0, which we don't write because it's just 1. Awesome. The red ones where things get a little messy. So if you look, yep.
How come like if we get like an x and another x?
Okay. The red ones where things get interesting. Because we have 4 divided by negative 4 in the fraction when we look at the numbers. the negative on the bottom actually would affect the negative out front. So you have this like subtraction sign right here. It's like subtraction signs attach that coefficient. So if I have -4 divided by -4, a negative divided by a negative is now a plus sign. So I now have a positive instead of a subtraction. And then 4 divided by 4 is 1, which we don't write. So even though this negative was a subtraction sign, they would turn into a positive. We count it as a negative. When you have a cubed divided by a, we subtract the exponents, it becomes a squared. We have b cubed divided by b squared, that's b. Yep. In the red one? In the blue one? So I have b squared divided by b squared, which is b to the power of 0. And b to the power of 0 is 1. So we don't write it. You could. So if you want, you could put times 1. We just don't usually write times 1. So if you put it, that's fine. It's just not the standard way to write a question. Yeah. Yeah. Because what they're dividing to be is 1, right? And we just don't write 1s. So if you want to, like, you can imagine there's a 1 out there, but we just don't write it. If we look at the green one, we have positive 12 divided by -4. Positive divided by a negative is a negative. 12 divided by 4 is 3. A divided by a is a. B to the 4 divided by b squared is b squared. Answer would be -5a to the 4 plus a squared b minus 3ab squared. Bigger questions, they don't really get harder, right? Like, stick to your process and you'll be good. I want you to try this on your own so you see if you got it or not. That negative here on the division, that's like a -1, right? So imagine there's a 1 there. So try to distribute that and try to divide. I'll give you a couple minutes. You should have distributed that to everything. So you should have ended up with this, like -1x cubed y squared on each one of these. If you didn't write -1 and you just put negative, that's fine. That's how it should be. Okay, we do each term at a time. So if we look at the first term, 3 divided by -1 is -3. Sometimes we use some rules, right? So when I have actual coefficients, I am dividing. So I did do 3 divided by 1 in my calculator. When it comes to dividing exponents, that's when I subtract. So just try to keep your rules straight, right? These numbers still divide, only exponents subtract. So 7 minus 3 would be x to the 4, y to the 5, y to the 2, y to the 3, because I subtracted my numbers. The middle term, a negative divided by a negative should have turned to a positive. Check your answer to make sure you have a plus symbol, not a negative symbol. 2 divided by 1 is 2. X cubed divided by x cubed cancels out. Y to the 4 divided by y squared is y squared. The third term, I have an invisible. Joe. If you look at the third term, I have an invisible +1, right? I put it in the red there. +1 divided by -1 would become negative. X cubed y squared divided by x cubed y squared. This is the same thing divided by itself. That equals 1. So you have to have a subtract 1 in there. That's the people probably don't get right. So make sure you have a subtract 1.
Did you have like a subtract x?
No, because that means you still have x's, but we don't have any x's, right? The x's are all gone. So that's why it has to just be a 1. If you look at fourth spot, negative divided by negative is a positive. X to the 4 divided by x cubed is x. Y to the 5 divided by y squared is y cubed. I subtracted the exponents. Check your answer. Make sure it's right. My guess is if you're wrong, it probably has to do with symbols. So look at your positive and negative symbols to make sure they're correct. Awesome. We're going to do algebra tiles because it is part of our world. It's not that bad. Again, the more important, in all honesty, is the algebra that we just did, because that's the thing that's going to apply forward in your life in math. The algebra tile, probably not as much.
Yeah, that's kind of communist.
When it comes to the algebra tiles, for division, they still kind of set it up as an area diagram. So what this actually represents is if you take the inside here, this is x squared, x squared, x squared, x squared, so 4x squared. And then there's 1, 2, 3, 4, 5, 6 x's. The inside actually represents 4x squared plus 6x. We put that in brackets. Yep. And we actually divide by one side they gave us, which was x, so 2x. That's what this represents.
So in the brackets, that's the whole thing.
Yeah, that's the inside. What it is, it's like the reverse of a product, right? And that's what division is. Division's the opposite of multiplication. So now they've set it up where they already gave you the answer, and they want you to reverse the multiplication to figure out what the answer is. So that's why it looks kind of the same as what we did before. What?
Would it be 2x squared plus 3x?
You're close. Joe.
Oh, wait. So like the 2 on the start are like, that's the squares. Okay.
Yeah. So like the way that I do this, if I look at the algebra tiles, I know that algebra tiles work by just having something that go on top of each other, right? So if I'm looking just strictly at the algebra tiles, I ask myself, what algebra tile would have to go in this area so that it created an x squared when I multiplied by x? Yeah, it would have to be an x tile. Right? That x tile would create an x squared. Yeah. And then I just keep doing that all the way across so I can figure out what each column is. So if I look at the second column, I ask myself, what would need to go in this area up here so that it created this x squared here? And again, it would be another x. Because an x tile and an x tile would come together to create this x squared situation. I keep going. The next column is this x right here. I know I have one x in a row, so it would actually just take one little square like that to create that x. And the same thing for the next 2 rows. So the answer to this would be 2 x's plus 3.
We didn't need the x on the end?
No.
I was still really close though.
You were close.
And for a guess?
Not bad. The answer is 2x plus 3.
Can you do that with any other?
Yeah, so algebra tiles are super limited, right? It's why it doesn't really carry forward. But if you had only x squares in the brackets and no other letters, you could do it. So as long as it doesn't go above x squared, you could use algebra tiles. We just don't have a way to represent x cubed. We don't have a way to represent xy. We just don't. So as long as inside the brackets is limited to the greatest exponent of 2, then you should be good. Yep. 7. We're going to do the same thing, but now there's some negatives mixed in here. So we're going to ask ourselves, looking at these algebra tiles, what column would create this x squared? And for us, we understand that it would be
X.
a long skinny tile of x would then match up with the other to create x squared. I do the same thing right here to create the next squared.
Wouldn't it be 2x plus negative?
You're close.
No, I know it would be 2x plus negative 1. It actually
So
be
if-
x.
So if you look at the third spot, that one's a little trickier because we have a positive x and it turns into a negative x. So we should understand the only way you get a negative is by having a positive times a negative. So that means up here, this has to be a negative 1 instead of just a positive 1. My answer would be 2x minus 1. The mathematical step that we did 6x squares minus 3x's, and we divide that by 3x. We got 2x minus 1. Right? We're just working backwards. The inside of the algebra tiles is now the inside of your brackets, and you divide by one of the outsides. This guy. So, no, we're just going to keep going, but thank you. Okay. Yes, sir. So if you look at this one, I have negative x here on the side. I want to create a negative x squared. I already have one negative, so the other one has to be a positive x. This one would also have to be a positive x because it's creating the same scenario of negative x squared. The next ones are trickier. So I have a negative x on the left row. The column somehow creates a positive x on the inside. The only way you get a positive is if you had a negative times a negative. So that means this is a negative block up here. Because a negative would create that positive. And again, I just do all negatives all the way across.
Okay, those are negatives?
Yeah. Don't shade it in, we call them negative. Sorry, the answers are shaded in, yes. So the way we would create a positive, if I already had one negative, is to have another negative. Right? A negative and a negative create a positive.
Oh.
Yeah, so you gotta think of how you could cancel out the other negative. Mathematically, we just did the inside of negative 4x squared plus a lot of x's there. 1, 2, 3, 4, 5, 6. There's 12 plus 12x divided by negative 2x. That's what we just did, but with algebra tiles. And your answer was 2x minus 6. Awesome. If we look at this guy, we could actually work it backwards too. If they only give you the inside, there's actually multiple answers for the outside. So we'll look at they're both the same, right? If you look at both algebra tiles, they're both the same. Both x squared and x. And there's actually two answers, but multiply to create them. The first answer is usually a little more obvious. So if I wanted to create an x squared, I would have had to have an x term here and an x term here. Right? That kind of makes sense. That's the only way to create that x squared in the middle. To create the x along the bottom, you would have had to have a single one times an x. So that makes sense. That's usually the one people get. They're like, yeah, okay, I get that. I can have x plus 1 times x equals x squared plus x. That makes sense. But there is a second answer. And the second answer just comes from understanding negatives. So if I look at x squared, it's positive x squared. I can get a positive by doing a positive times a positive, but I could also get a positive by doing a negative times a negative. That would create a positive x squared. And this one would also be negative because negative 1 times negative x created positive x squared. An x, positive x. So the same diagram has two different answers. One of them is all positives, one of them is all negatives. And just come understanding that like positive numbers could have come from positive numbers or it could have come from two negatives canceling out. That's all we're trying to get to.
That's the one part of math that's always confused me.
Yeah.
But a negative times negative equals positive.
Yeah, that is
Makes no sense.
It doesn't make sense. I agree.
Mathematician agrees with me.
If you look at part C, it says list the possible factor combinations. That word, factor, that's the things that divide into it. So my factors for this question would have been x plus 1 and x, or it could have been negative x minus 1 and negative x. So it's like the things that would multiply it or the things that could have divided into it. That's what the word factor means. We don't do a crazy amount with factors this year. Next year, we do a whole unit basically on factoring. And the years after that, you have to do factoring all the time.
So in other words, factoring is one that we need to understand.
Yeah, it's going to become important. I'm going to leave this one for you. I'll put up the possible answers so you can see if you can kind of figure it out. Ask questions if you want. But this one, I would have to have a positive x here, a positive x here, a positive x here to create the positive x squared middle. And then we could have a little negative box right there to create the negative x's in the middle. Then you could just do the reverse, right? So now instead of having a positive x squared or positive x on the top, I have negatives on the top. That means I would have had to have a negative x on the side to create that positive x squared in the middle. And I would have had to have a positive x single to create the negative x's in the middle. It's just the opposite. So my possible factors would have been x minus 2 and 2x. Or I could have done the reverse of it. I could get a negative x plus 2 and then negative 2x. Just the idea that you do the opposites if you don't know what multiplied becomes something.